Interesting integral. This one's not easy. Well, at least it's not very easy. Okay, let me start with this. I'll change this one into integral from 0 to half pi sine x log sine x and dx. Well, you can use this formula. You can use this formula, or you use substitution. Let t be, let x be half pi minus t. You can change this integral to that by using substitution. See, either way, use this formula or use substitution, and I can change this one to that. Well, because I'm dealing with the sine is better than cosine. Okay, then I use substitution. Let x equal to 2t. So this integral becomes from 0 to quarter pi now, and sine 2t, right? And log sine 2t. Sine 2t is 2 sine t, right? Cosine t. Dx is 2 dt. Yeah, very good. Then I can split this integral into 3. Okay. Let me put 2 outside. The first integral is integral from 0 to quarter pi sine 2t log 2, right? dt. That's the first one. And then plus 2, this 2. Have to work carefully because it's easily make a mistake. This will be sine 2t would be 2 sine t cosine t times log sine t and dt. Right, that's the second one. Plus the other one, the last one. Okay, it's this is 2 sine 2t is 2 sine t cosine t times a log cosine t dt. Wow. Let me check. Okay, this one is this. This one is that. This one is this. Okay, good. Now then, this integral is easy. 2 log 2 is outside, right? 2 log 2. This integral is negative half cosine 2t, right? From 0 to quarter pi. Yeah, that is this integral. This integral, next one is 4 sine cosine log sine. I can change it into sine t log sine, and the cosine dt is a d sine. Wow, it's good. Now the next one is 2, no, 4. 2 times 2 is 4, right? From 0 to quarter pi. From 0 to quarter pi. Sine, cosine, cosine. It could become cosine t log a cosine t and a d cosine t, which is negative. So I change the negative sign. Very good. So this one is equal to this is negative log 2. This is a negative 1. Okay, so that is the first one. The second one, sine, sine, sine. This one is cosine, cosine, cosine. So I can let the u be sine t, v be cosine t. For these two integral. So this becomes 4 u log u du, right? Now the boundary has been changed from 0 to root 2 over 2. That is for quarter pi for sine. And this one minus v dv d v log v dv. V log v dv, because v is a cosine. And this one is equal to 0, cosine is 1, quarter pi is root 2 over 2. So this one equal to log 2 now plus, okay, uv just dummy variables, right? Let me write for, well, x log x dx. Same thing. For this negative, I switch the boundary from root 2 over 2 to 1. So v and x just dummy variable, right? X log x dx. Yeah. 4. I forget 4. Plus 4. There's a 4 here. Okay. Now, and these two integral can be put together, see? Right? This is plus 4 from 0 to 1 now. These two becomes x log x dx. Well, things are getting better. Now, I use by parts for that integral. This is log 2 plus 4. This is u, this is v, right? So x squared log x from 0 to 1 minus 4 v du. This is v. Du is the derivative of this with respect to x. That will be log x plus 1. Yeah. This is log 2. Well, this value, well, when x equal to 1 is a 0. When x equal to approach to 0, then I'm using this log x over 1 of x squared, right? Using L'Hopital's rule. Then equals 0 is infinity. This is infinity. So this the derivative of this the derivative will be negative, right? 2x3. So this one is going to 0. So okay, that is obvious by using L'Hopital's rule. Now for this one is a minus 4, 0 to 1 x log x dx minus the integral 4, right? I always forget 4. 4 from 0 to 1 x dx. Yeah. Now, okay, and take a look this line and this line. They are equal. See, we deducted things line one after the other, so they are equal. So this cancel out. If I move this one over there, right, that would be 8 x log x dx would be equal to negative 4 integral 0 to x dx. Right? Okay. This line is equal to that line. This cancel out. This move there is 8 is equal to this. So this one is equal is minus 4 to a half x squared from 0 to 1, right? So this one is equal to negative 2. In other words, this log x is equal to negative quarter. This is equal to negative quarter. Now, what is my I? My I is equal to this. I is equal to, well, I is equal to log 2 plus 4 times this, right? 4 times this. So finally, the answer is this. This is my value for this definite integral. Well, this is a very good exercise for basic training in calculus. Well, I think you better do it by yourself, from beginning to the end, and you really improve your techniques of integrations. Thank you.